Motion of a charged particle in uniform magnetic field. When a charged particle enters in uniform magnetic field, then it experiences a force, and that force is given by QVB sine theta, where theta is the angle between the direction of the magnetic field and the direction of the motion of the particle. So here two possibilities are there. When theta equal to 90 degrees. In that case, F equal to QVB will provide centripetal force. And because of this centripetal force, particle will move in circular path. So let's find out the radius of the circular path. So we can say that mv square divided by r equal to qvb, which will give r equal to, from here it is one we will cancel out, mv upon qb. Now we can find time period. Time period is 2 pi r divided by v. We put the values 2 pi divided by v, and in place of r we write mv upon qb. So we will get 2 pi m upon qb. From here we can get frequency, which is 1 upon time period, and that will be equal to qb divided by 2 pi m. Now let's consider the case when theta is acute. In that case, the situation will be little different. So suppose this is the direction of magnetic field, and this is direction of the charged particle. So velocity is making angle theta with magnetic field. So there will be two components, one perpendicular component and another parallel component. So perpendicular component will be V sine theta, and parallel component will be V cos theta. Here V sine theta will provide centripetal force, and V cos theta will lead the particle forward, and the particle will follow a trajectory like this, which will be a helix. And this distance, which is distance covered in one time period, is called pitch. So we will try to get the relation for pitch, and we will do some numericals thereon. So let's write the radius in this case. So the radius will be mv perpendicular component divided by qb. And we know that perpendicular component is v sine theta. So it will become mv sine theta divided by qb. Let's find out time period. So time period will be 2 pi r divided by v perpendicular. So it will be equal to 2 pi divided by perpendicular component is v sine theta, and then we write the value of r as mv sine theta divided by qb, which will give 2 pi m divided by qb. Let's find out pitch. P equal to parallel component of velocity times time period, and parallel component of velocity is v cos theta times time period is 2 pi m divided by qb. So this is our expression. Now let's understand it by doing some numericals. So question number 1, an electron moving horizontally with a velocity of 4 into 10 power 4 meter per second enters a region of uniform magnetic field of 10 power minus 5 Tesla, acting vertically downwards as shown in figure. draw its trajectory and find out the time it takes to come out of the region of the magnetic field. So here, this is uniform magnetic field. In this direction of electron, we have to show its trajectory and we have to find out the radius of its path. So we can say mv square upon r will be equal to qvb because theta is 90 degree. So from here we can get r equal to mv divided by qb. We put the values 9.1 into 10 to the power minus, sorry, mass of electron is 10 power minus 31 times velocity 4 into 10 to the power 4 divided by charge on electron is 1.6 into 10 power minus 19 into magnetic field is 10 power minus 5. So from here we get R equal to 22.75 times 10 to the power minus 3 meter or 2.275 into 10 power minus 2 meter. Now let's find out time period. So time taken to come out of the region of the magnetic field. So particle will enter and then it will follow the circular path. So suppose particle enters at this point and then it will follow this path. So it will describe semicircle and it will come out. So we can say this distance is pi r. So pi r, so t will be equal to pi r divided by velocity. So we put the values pi into r. R is this much 22.75 into 10 to the power minus 3 divided by velocity is given in our question 4 into 10 power 4. So 4 into 10 to the power 4, we put the value of pi 22 by 7 times 22.75 into 10 power minus 3 divided by 4 into 10 to the power 4. So we evaluate it and that comes out to be 1.8 into 10 to the power minus 6 second. Now let's take another question. An electron, after being accelerated through a potential difference of 10 power 4 volt, enters a uniform magnetic field of 0.04 Tesla perpendicular to its direction of motion. Calculate the radius of its trajectory. Here, all informations are given. So, voltage is given as 10 power 4 and magnetic field is given as 0.04 Tesla. Charge on electron, we know that E equal to or Q equal to 1.6 into 10 to the power minus 19 Coulomb. And the mass of electron also we know it is 9.1 into 10 to the power minus 31 kg. So we can write, since the electron is accelerated through potential, so it will acquire kinetic energy. So 1 by 2 mv square equal to electronic charge into potential difference. We get the value of velocity from here. Velocity will be 2 ev divided by m square root. So 2 ev divided by m square root. So we have got the velocity. Now, since electron enters in magnetic field, then it will follow the circular path. So we can say mv square upon r must be equal to qvb or evb. So we can get r equal to mv upon qb. So we put the values. So m upon qb times velocity is this much 2 e capital V divided by m, or it will become root 2 m e capital V divided by qb. We can put the values. So it will become root of, we have to put all values, 2 into 9.1 into 10 power minus 31 into electronic charge 1.6 into 10 power minus 19 into voltage 10 power 4 whole divided by electronic charge 1.6 into 10 power minus 19 into magnetic field 0.04. So if we evaluate it, it will come out to be 8.43 into 10 to the power minus 3 meters. Now, let's take one more question. Question is, a beam of protons enters a uniform magnetic field of 0.3 Tesla with a velocity of 4 into 10 power 5 meter per second in a direction making an angle of 60 degree to the field. Find the radius of the helical path and also find the pitch of the helix. Charge of proton is E equal to 1.6 into 10 power minus 19 coulomb. Mass of proton is 1.67 into 10 power minus 27 kg. So here we have to find out the two components because here theta is given. So this is theta, which is given as 60 degree. This is V. So it will become V cos theta in this direction, that is V parallel, and V perpendicular will be V sine theta, where theta is 60 degree. So let's find out what is V parallel. So V parallel will be V cos 60 degree, and V is given as 4 into 10 to the power 5 into cos 60 is 1 by 2. So it will give 2 into 10 to the power 5 meter per second. Similarly, V perpendicular, that is V sine 60 degree, that is 4 into 10 to the power 5 into sine 60 is root 3 by 2. So this will come out to be 3.46 into 10 to the power 5 meter per second. So we have got the two components. Now we know that radius will be equal to mv perpendicular divided by qb. So we put the values. Mass of proton 1.67 into 10 power minus 27 into v perpendicular is 3.46 into 10 to the power 5 divided by qb, charge on proton 1.6 into 10 power minus 19 into magnetic field is given as 0.3 Tesla. So 0.3. We put this value. So this comes out to be 1.2 centimeter or 12 into 10 to the power minus 3 meters. Now let's find out period of revolution. So period of revolution t equal to 2 pi r divided by v perpendicular. So this will be equal to 2 into 3.14 into radius 12 into 10 to the power minus 3. Recently we have evaluated and divided by v perpendicular is given as 3.46 into 10 to the power 5. And this will come out to be 21.35, sorry, 21.75 into 10 to the power minus 8 seconds. Now we have to find out the pitch. Pitch equal to V parallel multiplied by time period. So V parallel we have evaluated as 2 into 10 to the power 5 into time period. We have just got this 21.75 into 10 to the power minus 8. So this will come out to be 43.5 into 10 to the power minus 3 meters, or we can say it is 4.35 into 10 to the power minus 2 meters, or 4.35 centimeters. Thank you for watching.